Today we're talking about 1.2 vocab, and we're starting off with angle. Most of you know what an angle is, and here's the definition you need to put on your card. But I'm going to go through and give you a picture to represent it and also an example. Alright, so we have an angle formed by two rays, or they could be line segments or lines, that share a common endpoint. Okay, and those rays or lines or line segments will be the sides of the angle. So here, if in the picture box, we're going to draw two rays with a common endpoint. So they both have that same endpoint. Okay, this is the angle formed between them. So that's an angle. Okay, we name angles a couple of different ways. Okay, they can be named with 3 letters or 3 points. So you have your common endpoint here, we can call X, and a point on each of the rays. Okay, and if you're using 3 points, you have to do it with the vertex point, or that common endpoint, as the center letter. And then there's a symbol that represents angle that goes in front. So we would say angle. Okay, and you can write that curve on there if you want. You don't have to though. That's typically how you will see me write it. So this would be angle Y, X, Z. Okay, or you could do Z, X, Y. If you want to get in the habit of tracing it to see what order the letters would go in, just make sure that common endpoint is the center letter. And the symbol goes in front, not on top, like when we were doing lines and rays. Okay, the second way you could name it is with just a single letter or a single point. Okay, so if you were only given this common endpoint and there's only one angle in the picture, you can't be confused as to which angle it's talking about. You could just call it angle X. And the third way is with a number. This could be numbered, any number. So if this was labeled like this, you could call this angle 1. Alright, so you have 3 ways to name angles. Alright, let's look at an example. If you were asked to draw angle CAT. Okay, there's several ways you could do that. It could open in any direction. Okay, I'm going to do it with 2 rays with a common endpoint. Okay, so I have an angle and they specifically want it to be called CAT. So that center letter A has to be this common endpoint. So I know that has to be A, and then C and T can be points anywhere on either of those 2 rays. So this one could be C, and this one would be the opposite, which would be T. So this would be angle CAT. Okay, so that's it for angles. The next vocab word you have is vertex, and you might have heard me say that in the last slide. The vertex is what we call that common endpoint of an angle. So in a picture, you could draw that same picture we had for angle a second ago, and just realize that the vertex is this point here, the common endpoint. That's the vertex of the angle. Okay, and that vertex will always be the center letter when you're naming an angle with 3 letters. So vertex will always be center letter when naming angles. And again, I'll abbreviate a lot. I'll use symbols to write more quickly. So when you see this, that's angles. Okay, and I think I said in the last slide or the last card, these are the sides of the angle. So you have the vertex and 2 sides of an angle. Alright, as an example, if you were given a drawing, let me get green. you're given this drawing and told that this is X, Y, Z, and you're asked, what is the vertex? Okay, in a drawing it's pretty easy to tell. You just look at the corner or the common endpoint and say, well, it's Y. So Y, point Y, is the vertex of this angle. Okay, if you're given not a picture, you're just given the name of an angle, you're told the angle is called, so this is another example if you can fit it on there somewhere, your angle is called BAD. What's the vertex? It will always be the center one. So point A would be your vertex. Alright? Next one is congruent angles. Congruent angles are formed if and only if they have the same measure. And we measure angles in degrees. So they could be connected or not connected. So here if we have an angle and then another angle here, they would be congruent if they have the same measure, the same number of degrees between them. And there's a couple of ways we can mark it. We can mark with these arcs, and if they have the same number of arcs, they're congruent. That's how we label them congruent. Okay, you could use 2 marks. Okay, as long as they match, they are congruent. And I'm going to go ahead and name these so you can see what a congruence statement looks like. We did congruent statements in 1.1 for congruent segments, but we're also going to do them for angles. So I'm going to say CAT and DOG. Okay, so the congruent statement for this would read angle CAT is congruent to, remember this is the symbol for congruent, angle DOG. And notice I made sure that my vertex was the center letter of both of those angles. I'm also going to do in the example, I'm going to show you another way you can mark angles congruent. And your congruent angles may not look congruent to you, but if they are marked, okay, if you're told by markings, then you assume they are congruent. Okay, so rather than the number of arcs telling us they're congruent, you could have an arc with various numbers of tick marks on it. So I could have 2 tick marks and 2 tick marks. That is also a way to mark angles congruent. Okay, so make sure that you know you could do it with tick marks or just additional arcs. Alright, so these 2 angles are drawn as congruent, labeled as congruent for you, and they ask you to write the congruent statement, just like we did in this picture. Okay, I want y'all to try and do that, and I'll check them tomorrow in class and see if you were able to get them right. So these points will be called P, M, N, and H, J, K. So I want you to try and write a congruent statement for that, and I'll check them in class tomorrow and make sure you're able to do it. And you can look at this in purple as a reference to see if you're doing that right. Last card for 1.2 is angle bisector. An angle bisector can be a ray, a line, or a segment that contains the vertex of an angle and divides the angle into 2 congruent angles. Okay, so long story short, bisector we know means cut in half. So if it's an angle bisector, it's cutting an angle in half. Okay, so if we have an angle made up of these 2 rays, and in comes a third ray with a common endpoint, so it has to go through the vertex, and it divides this angle equally, and you would have to see it marked to know that they are equal. Okay, so if this purple angle is cut in half by this ray, then that ray is an angle bisector, because it cut this ray in 2 equal parts at the vertex. Okay, and you may read a sentence or a statement in math terms that would read like this. Let's name some points on here so we can come up with this statement. L, M, N, O. So if we read this, it would read that angle LMN, that's our original angle, is bisected by ray MO. And remember, when you're naming rays, you have to start with your endpoint, okay, and then the symbol goes in that direction. Okay, so for your example, I want you to try, let me get a straight line here. If you're given this angle and asked to draw the angle bisector, okay, you could use a line segment array or a line to cut it in half, but to show that it's actually bisecting it, you need to make sure that you put the markings on there, marking these 2 pieces congruent. Okay, so that's how you would mark it to show that it's an angle bisector. Okay, and that's it for 1.2. Make sure you bring your note cards to class tomorrow so we can do an activity with those.